Hello guys, welcome to another video. This one is paper 2-2 of October-November 2011, Add Math paper 2. So this one is actually the paper that I took when I was doing O-levels. So let's see how you guys do in this paper. So let's move on with question number 1. So back then we used to have the questions of set. Now it has been removed from the syllabus, so obviously we don't need to do this question anymore. So this one, we don't need to know about this question. Now let's move on to question number 2. So on the grid below, we have to draw on the same axis for this is the domain, right? Between 0 and 180, the graph of y equal to sine x and 1 plus cos 2x. Now again, as you can see here, we have draw. So usually we have sketch. Whenever it says draw, so you have to try your best to make it as exact as possible. Draw has to be exact diagram. This is why they gave you a graph to show your work. Now, let's try my best. So let me find something to help me to draw my lines. Since I don't have a ruler, let me use a piece of paper to try to see what I can do. Now, to begin with, the same method applies here. So how do you draw a curve? So usually we begin with a table of values. Let's begin with the first one, which is y equal to sine x. Right. Now we have the value of x and find the corresponding value of y. Now x is between 0 and 180, so let's begin one by one. So begin with 0. So y will be 0. And then we have what? We have 90. So we can always begin with 90. So we always want to begin with the interval of 90. But now, it depends on this as well. If the coefficient of, so basically here we have this, right? X. Now, in front of x we have 1. Usually what we do is, if you want to work with exact values, you will take 90, divide by the number before the x, which is 1. You will get 90. So this means that we will work with the interval of 90 to work with exact values. So 90. So let's see what is sine of 90. So here, because it is in degrees, so we have to keep your calculator also in degrees so that we have consistent values. Okay, degrees sine of 90, that will be 1. So here it is 1. Next one will be 180. Right. Sine of 180, let's see what happens. And that will be 0. Okay, that is for the first one. Now let's move on to the other one, which is y equal to 1 plus cos 2x. So here we have y equal to 1 plus cos 2x. Now again, same thing applies. We have the values of x, find the corresponding values of y. Now again, the same idea here. Because the coefficient of x is 2, the interval we will have to use will be something different. So as you can see here, we did was 90. We begin with 90 and divide by this 2, that will be 45. Okay, so 45 degrees will be the interval that we will work with in this one. Begin with 0, obviously, then will be 45, 90, 135, and 180. Okay, so let's see what are the values that we have for this one. That will be 1 plus cos 2 times 0 is 0. That will be 2. 1 plus cos 2 times 45 is 90. That will be 1. 1 plus cos of 180, right? 2 times 90 will be 180. That will be 0 again. And we have 1 plus cos of, this is 270. That will be 1. And cos of 360. That will be 2. As you can see, these are the values that we have to plot on the graphs and join them to form our curve. Now, one by one, now we have to plot the axes. Now we can draw the y-axis on this side. Right. Now here, because we don't have any negative values on the y-axis, based on the table of values, we can just draw the x-axis. I would say we can just draw this here because we don't have any negative values. It doesn't go down. We can just connect here. Right. Here you go. This is my x, and this is the y values. Okay. Now for the first one, for our sine, let's first try to mark my axis first. So this is 0, right? This is let's call this let's take this 1 and let's put this as 2, right? Just to help us to draw something accurately. Now obviously this is not the it's not going to be the best shaped diagram. You have to use a pencil so you can draw your curve as smooth as possible. The first one is going to be 0, 0. This is my first point for this one. And then let's put 90 here, right? 90 here. So this is 45. This is 135 and 180. You can stop right here, no big deal, right? So the first one is 0, 0. Then we have 91. So here you go, 91, and then 180. So that will be the other one. So let's join them. For this one, it has to be something like this. This shape going down, and should be in this shape as well. Okay, so that will be the first one. Let's label this as y equal to sin x. Now for this one, that will be 0, 2 will be this one. We have 45, 1, that will be right here. Then we have 90, 0, this one. And we have 135, 1, this one. And we have 182 will be this one. Now let's try to join them again. So we have what? So if you observe, this will be my point here. This is the maximum point. It will join with this shape, right? Something like this. Here you go. As you can see, and of course label this as y equal to 1 plus cos 2x. Okay, so this is the shape of my curves between 0 to 180 for this domain. So this is part 1. This is the shown as required. Now let's move on to part 2. So here we have to state the number of roots for this equation, this and this, between those two. Now, obviously, because we have drawn this above, you can see here we have state, which means we have to use the above diagram to show how many roots do we have. Now you can see we have 2 points of intersection right here. So it means that we have 2 solutions. Should be pretty easy. State, only 1 mark, means we have 2 solutions based on the diagram. Now, for part 3, without extending your graph, state the number of roots for the same equation, basically for the same graph, right? Now, just because here we have a different domain between 0 and 180. So now we don't need to draw the curves completely. So we have to understand what's happening. Look, if you guys don't know how to think about this, what to do? You can always plot a different diagram on the side between 0 to 180. So draw the graph completely so you know exactly what's happening. But if you have the main idea is that this curve, what happens is it will have to go up, go down, and then it will go down, it will be in this shape. For example, we have to understand that the sine curve will be something like this. Go up, down, right? And then it will have to go down and then go back up. That's the idea. Now, when it comes down to the cos curve, it is something like this. This and this, if that makes sense. As you can see, even though we extended the graph between 0 to 330, we still just have 2 points of intersection. So your answer will be still 2 between 0 and 360. So the idea is that you have to know what happens to the shape after 180 to 360. As you can think, it is not touching in this side. This is between, sorry. Let me write this. So between 180 to 360, you can see the curves are not touching. Because of that, we have no further solutions. It will be just 2. Now, of course, it says do not without extending. But again, as you can understand, no one is watching you what you're doing. You can always extend using your pencil and then erase it afterwards and write down the corresponding value so that you can be confident in your answer. That is your question number 2. Let's move on to question number 3. it is given that 2x minus 1 is a factor. So here we know this one is a factor of this expression. So first thing first, let's call this expression f of x. Now, you know that when your expression is divided by the factor, the remainder has to be what? The remainder has to be 0 when divided by a factor of that expression. Now, what is the value of x? So pretty easy. We just have to equate that to 0. So we have 2x minus 1 equate to 0. X will be 1 over 2. So that is the value of x that we have to use. So the idea is that if f of half should be equal to 0 because it is a factor. So the remainder theorem says that if my function takes the value of x as half, the remainder has to be 0. So this is my first equation that I can use in this question. Let me simplify this to see what happens. Replace this here, you will have 4 times 1 over 8 plus a times 1 over 4 minus 11 over 2 plus b has to be 0. So that's the equation we can use. Now we have to simplify. That will be what? That will be 1 over 2 plus a over 4 minus 11 over 2 plus b equal to 0. Now, times 2. We can times 4 everywhere because we want to eliminate the denominator. What will happen? So, that will become 2 plus a minus 22 plus 4b has to be 0. Simplify. That will be a plus 4b. That will be minus 20 is 0. A plus 4b equal to 20. This is my equation number 1. Now we will have to use it somewhere afterwards to find the values of a and b. Now, continue. And that the remainder when the expression is divided by this now is 25. So again, find the value of x. We equate that to 0, which means x has to be the value of minus 2. Now from this we understand that if f of the function takes the value of minus 2, the remainder is given to you by 25. So that is my equation number 2 that we have to simplify and see what happens. So let's see. So here we have what? Here we have minus 2, so we have to replace back in the equation. That will be 4 times minus 8 plus a times 4 minus 11 times minus 2 plus b has to be 25. Now simplify. That will be minus 32 plus 4a plus 22 plus b is 25. Now 4a plus b has to be what? So that will be 25 minus 22 plus 32, that should be 35. That is my equation number 2. Now, we have to just read what are we trying to find here. So we have to find the remainder when the expression is divided by this. So this is pretty easy as well, but first let's find the values of a and b. As you can see, these are the 2 unknowns for now that we can find first and then eventually find the required answer that we need for the question. So here let's make a become subject. A will be 20 minus 4b. Replace a. In here you have a times a is 20 minus 4b plus b has to be 35. Now simplify. That will be 80 minus 16b plus b has to be 35. Simplify. That will be minus 15b. That will be 35 minus 80. That will be minus 45. So finally b has to be this divided by this, that should be 3. And then a has to be 20 minus 4 times 3, that should be 8. So this is the value of b and a. So what can we conclude here is that we have found the value of f of x. From this we know that f of x has to be what? Has to be 4x cubed plus a is 8, x squared minus 11x, and then plus 3. So that's the first part of the question. Now we have to find the remainder when it is divided by this. Now pretty easy. When we divide by x plus 1, we have to equate that to 0, which means the value of x has to be minus 1. So we have to find the value of f of x when it takes the value of minus 1. So 4 times, that will be minus 1, plus 8 times 1 minus 11 plus 3. So let's see what happens. That will become minus 4 plus 8 plus 11 plus 3. Minus 4 plus 8 plus 11 plus 3, that should be 18. Okay, so this is the remainder that we have by dividing by x plus 1. This is your question number 3. Let's move on to question number 4. So this one is a matrix question. As you guys know, this has been removed from your syllabus of Add Math, so we don't need to be doing this question. Let's move on to the next question. Here we have question number 5. Now, here we have 4 boys and 3 girls. They are seated in a row. Okay, so 4 boys and 3 girls. That's the first thing given to you. Now, we have to find the number of ways that this can be done if, part 1, if the boys and girls sit alternately. So, let's see. So now, first question is that a combination question or is that a permutation question? Now we have to think. Because the boys and the girls, or the boys or the people, they're different people, if that makes sense. For example, if you pick 2 boys in your class, they are 2 different people. So because they are different, and because here, as you can see, the order matters, because we have to sit alternatively and all that stuff, because of that, it is going to be a permutation problem. Now, that's the first thing we have to realize. Now, let's see what is possible. So we have, in total, we have 7 people. So let's put 7 space. 1, 2, 3, 4, 5, 6, 7. So now, we have 2 ways to think about this problem. Sorry about that. So let me write this again. So 1, 2, 3, 4, 5, 6, 7. Now, you may tell me, hey, you know what? At first, we can actually, let's put a boy first. So you'll have to put a boy. And then we put a girl, we put a boy, we put a girl, we put a boy and a girl and then a boy, right? This is my first way of arranging them. Now, you may also argue that, hey, why can we not put a girl first? Let's try. If you observe, girl, boy, girl, boy, girl, boy, and boy, because we only have 3 girls and 4 boys. Because we will end up with something like this, this will not be an eligible option. So we have only one way of arranging them, which is this. Okay, so one by one. So first, to put a boy here in the first place, for the first option, we have 4 boys to choose from. So we have 4 options. And then multiply. Here we have 3 girls to choose from. And then we will have, afterwards, we will have 3 boys. And then 2 girls, 2 boys, 1 girl and 1 boy. So this is your answer for part 1. 4 times 3 times 3 times 2 times 2 times 1 times 1. That should be 144 for your answer. That is part 1. Now for part 2, the boys sit together and the girls sit together. So now, because they sit together, we have to look at them as one object. For example, here we have 4 boys and 3 girls, right? Let's make them become one object. Basically, this is 1 and 1, which means we have 2 in total, right? Now, because of that, we can only have 2 places because we see them as 2 objects now. Now, when we have 2 places, we have 2 factorial ways of ordering them, right? Because we think about, oh, we can first put 3G, or we can put this here, or it could be 4 boys and 3G. That's why we have 2 ways of doing that. That's the first step. Now, once you read this, we have to understand that inside of the group, when they are together, they can rearrange them among themselves. So what do I mean? For example, you have boy 1, boy 2, boy 3, and boy 4. They are in the group. They sit together. Now, in the same group, now I can rearrange all these boys. For example, I can first put boy 2, boy 1, boy 3, and boy 4. So as you can see, this is a different arrangement as this one, it will be. So now, because we have 4 different boys, we will have 4 different ways of arranging the boys in this group. Now, same logic applies because we have 3 different girls. We will have 3 different ways of arranging them. So your answer will be 2 factorial times 3 factorial times 4 factorial. That should be 288 as your answer. Now let's move on to part 3 of the question. A boy sits at each end of the row. Now we have 4 boys and 3 girls. We have 1, 2, 3, 4, 5, 6, 7. Now for us to put a boy here, we will have 4 options, right? We have 4 boys. And then for us to put another boy here, we will have remaining 3 options, right? And now for everything in between, there's no special condition. We will have, so 4 minus 2, we have 2 remaining. In total, we will have 5. So 5 people to sit in these 5 places. That will be 5 factorial. Okay, that will be 4 times 5 factorial times 3. That should be 1440 as your answer for part 3. And that is your question number 5. As you can see, these kind of questions, they're not hard. You just have to understand and think logically what is possible, and then proceed step by step to find the number of solution that we have for their seating. Now let's move on to question number 6. Here we have the length of a rectangular garden is x meters, okay, and the width is 10 less than the length. So 10 less will be x minus 10. Now of course in this case you can always make a diagram so that it can help you to understand what's happening. This is my rectangle, this is the length is x, and the width is x minus 10. Next one, part 1. Given that the perimeter of the garden is more than 140 meters, write down a linear inequality in x. So first thing first is, how do you find the perimeter? It is the distance around the rectangle. Pretty easy. That will be x plus this plus this plus this. So we know that this will be also x minus 10. So we have to add all the distance around to find the perimeter. So let's do that. That will be 2x minus 10. So that will be 2x plus 2x minus 20, and that should be 4x minus 20, and that is your perimeter. Now we know the perimeter has to be more than 140, so P is 4x minus 20 more than 140. Okay, as you can see, this is my inequality in terms of x. We can leave this just like this for now. Now for part 2, given that the area is less than 3000, so how do you find area of a rectangle? You know, it is a formula, length times width. The length is x, the width is x minus 10. That will be x squared minus 10x has to be less than 3000. So here we go. This is my inequality that we have for the area. That is part 2. Now for part 3, by solving these two inequalities, find the possible set of values of x. So let's solve one by one. So of course you have to show your work here, but I will do this here itself. Here we have 4x has to be more than 160, so x has to be more than 40. That is my first inequality. Okay. Now for this one, let's see what do we have. So here we have to factorize and find the values of x. So because this one is a big number, sometimes I don't like to think too much. I will just try to find that using my formula. So let's do this. Let's find the critical values of x. That will be x is minus b plus minus b squared minus 4 times a times c. That will be this value. Over 2a will be 2. That should be 110. So basically x is plus minus 110 over 2. X can be 10 plus 110 divided by 2. It can be 60. Or it can be 10 minus 110 divided by 2. that will be minus 50. Now these are the critical values of x, right? Critical values. This is not your answer yet. We have to use the graph to find the values of x. This is the line 0. Because it is positive 1, it will have a shape like this, right? This is my value of minus 50, and this is the value of 60. Now as we can see, the value has to be less, so this will be the values here. So basically x has to be between minus 50 and 60. Now something we have to realize, what is x? X is the length, and the length cannot be negative, so length have always to be positive. Because of that, we have to deduce that from this the values of x have to be actually between 0 and 60. Okay, so now we have to use this and this to find the correct set of values of x. For example, here what do we have? Let's use a number line to help us to find the values. Here we have 0, 20, 40, and 60, for example. So for this set, it is between 0 and 60. So 0 and 60, it will be this. Right. Now, for this one, it will be has to be more than 40. So more than 40 will be here, and then keep going on. Right? But now, as you can see, they only meet in this region, right here. This is where they meet. So this is the set of values of x for which they are satisfied. So let's write this down. X has to be between 40 and 60. Okay, and this is your answer for question number 6. Let's move on to question number 7. In the diagram, AB and BC have arcs of concentric circles center O. Okay. Now, where OA is given to you by 6 and AB is given to you by 8. Okay. Now, the area of the region ABED is 32. So ABED, this one is 32 for the area of that region. Now, the triangle ACF is an isosceles triangle with OC, and OF is 20. So if this is 20, this means this has to be what? This part has to be, let's see, 20 minus 6 minus 8, that should be 6. Okay, either way, so let's move on to the next part. Now for part 1, we have to find the angle in radians. So how can you find the angle? Let's see, what can we use to find that? So the only thing I can use is, from what I can see, we can use the area to find that that angle. Okay. So let's see how would you find that value. So how would you find this area? So we have to look at two shapes here. To find this area, we have to first find the big area of OEB. So let's write down. To find the area of ABED, we must first find the area of OBE, and then minus the area of OAD. That makes sense, right? Now this is given to you by 32. Now what is the area of OBE? It is area of sector, so we can use the formula, which is half r square. This is the radius, that will be 14 square. And the angle here is theta minus half OAD, that will be 6 square and theta. Simplify. So that will be 32 half times 14 square, that will be 38 theta minus half times 6 square, that will be 18 theta. Okay, now let's simplify. What do we have? 98 minus 18, that should be 80, is 32. So theta has to be finally 32 divided by 80, that should be 0.4 radians. And this is your answer for part 1 of the question. As you can see, we always use the values given to us by the question, and we try step by step to find the answer by thinking logically, what can we do? Now for part 2, we have to find the perimeter of the region BCFE. Now where's BCFE? So BCFE, so we have to find that. So we have this side 1, 2, 3, and 4 to find. Now, as we know, 2 is 6, 4 is also 6, right? Because this is 20, this is 14, this has to be 6. Same thing, 6, 8, this has to be 6. Now, we can find number 1 pretty easily, because why? If you look at the sector A, so OBE, we have radius of 14. So if you take this out, we have what? We have this. This is O, this is B, this is E. We have the angle here, and we have radius of 14. So how do you find this one? Pretty easy. This can be found by using your formula of r theta. This is the length of arc. R is 14, theta is 0.4. 14 times 0.4, that should be 5.6. So this is 5.6. Now what about this one, number 3? If you observe, 3 is this side FC. Now as you can see, FC is part of a triangle right now. So let's write this down. Or let's take out the shape. So we have something like that, right? We have the angle here, 0.4. This is 20. This is 20. We have to find this side. Now, of course, there's many ways to do that. You can always break this down in exactly half and use SOHCAHTOA to find the side as well. Or we can just use the cosine rule, because we know these two sides and the angle in between. We can use the cosine rule. Okay, so let's find that. That will be my side number 3 by using the cosine rule. So cosine of the angle in between has to be 20 square, the sides on both sides of the angle, minus the opposite side will be the side FC square, divided by 2 times 20 times 20. So here we have to use radians because the angle were given in radians. So cos of 0.4 times 2 times 20 times 20, because we're just cross multiplying, that's why we times this part right here. You will have 736.8488. Okay, that will be, so 20 square plus 20 square, that will be 800 minus FC square. So FC square has to be what? 800 minus 736.8488, that should be 6315, and finally FC has to be square root of that. That will be 7.9468. That is my value of FC, which is number 3. But here we are trying to find the perimeter. We have to add all the sides together. So pretty easy. According to the diagram, it is number 1 is 5.6, number 2 is 6, number 3 is 7.946, and number 4 is 6. So let's add everything together to see what do we have. 7.946 and plus 6. That will be 25.5 for my perimeter. So this is part 2. 25.5 correct to 3SF to find the perimeter of that object FCB or BCFE, same thing. Now let's move on to question number 8. A particle travels in a straight line so that t seconds after passing the point O, its velocity, which is given by v by this equation. Good to know. Now part 1, find the value of t when v is equal to this. So pretty easy. V is this. That will be 12 cos of t over 3. So let's simplify. So which means cos of t over 3 has to be 1 over 6. Now given that this is positive, has to be in your first quadrant and your fourth quadrant. But usually we only deal with the first time of it happening, which is the first quadrant in this kind of question. Now t over 3 has to be cos inverse of 1 over 6. Here we have to use radians. 1 over 6, that will be 1.4033. Now finally from this, t has to be times 3, 4.21. Okay, this is your answer for part 1. This is the time at which the value of v is 2. Now for part 2, find the acceleration of the particle when time is 3. Now, We know the acceleration has to be equal to what? dv by dt. Let's first find that. So we have to use that. First thing is 12. 12 is only a multiple, does not change. Then d by dx of cos, that will be minus sine. The value is t over this, and then of course multiply by d by dt of this value, that will be 1 over 3. To simplify, that will become 1, that will become 4, minus 4 sine of t over 3. That is my a. Now we have to find the value of a when t is equal to 3. So replace back in my main equation. That will be minus 4 sine of 1, right? Let's see what happens. Minus 4 sine of 1, that should be minus 3.37 meters per second square. That is part 2 of the question. Now for part 3, find the distance of the particle from the point O when it first comes to rest. So at rest is what? At rest we know value of v has to be 0. Okay, so let's see. But here we have to find the distance from point O. We have to find the displacement of the particle. Now we have to understand. Let's first find the displacement. So displacement is equal to integration of v. So let's first find that. That'd be 12 cos t over 3. So let's continue here. This will give you 12 is the multiple. This will give you sine t over 3 divided by 1 over 3. That will become 36 sine of t over 3 plus c, obviously, for s. Now we have to find the value of c. We know that at time equal to 0, s has to be 0. That's the initial position. That will be 0 here. And then we have 36 sine of 0 plus c. So we conclude c has to be 0 as well. So finally we have the equation for s. S has to be 36 sine t over this for my displacement s. Now we have to find displacement s when it first comes to rest. So when it comes to rest, the value of v is 0. So we know v is equal to 12 cos t over 3 is equal to 0. Let's solve. That will be cos t over 3 has to be 0. So t over 3 has to be cos inverse of 0. That will be 90 degrees, which is pi by 2, right? And t has to be 3 pi by 2. So let's replace that back in my main equation. So s has to be 36 sine of 3 pi over 2 divided by 3. Simplify to see what happens. So 3 pi over 2 divided by 3. Sine of that value, we have to use radians, times 36. That will be 36 meters for my answer. And this is my question, number 8 for, this is kinematics, right? So we have to complete that in radians usually. Because I have this question most of the times, how do we know when to use degrees or radians? So depending on the question itself, because we have to understand that radians and degrees are the same thing, but given that we are working with kinematics, usually because of that, let's keep it to radians. It will help you to find the exact values. Now when it comes to time, as you can see, we will have to work with radians to help us with that. That will be question number 8. Now let's move on to question number 9. It is given that f of x is given by this expression. Now find the value of a, b, and c, for which we have this. As you can see, we have to complete the squares. So one by one. First step is we have to make sure the coefficient of x squared is 1. So let's factorize that outside. That will become x squared minus 6x. Now for this one, I don't like to put this in the same bracket. I like to just remove it outside. Right. Now I can proceed to simplifying this inside first. You have 2. Here we have x squared minus 6x. Now plus the value. That will be value of 6, right? 6 divided by 2 square plus 10. Now when you add something, you also have to minus the same value, so you don't change the equation. Because it was inside of this bracket, we have to also give it the 2. Now simplify. 2 will be outside. Here we have x squared, that will be x. Here we have minus, become minus. Here we have 3. Here we have square, that will become square. Now this one will become 2 times 3 square, right? that will be 18, and we have 10 minus 18, that should be minus 8. So here we have minus 8. So this is shown as required, expressed in this way. Good to know. Now for part 2, sketch the graph of this, between this and this. Here we have to only sketch, so basically it doesn't need to be exact. We just need to show an idea of how does a graph looks like. Now, because we have a domain, we have to find the corresponding values of y at these 2 points. When x equal to minus 1, what is the value of y, which is f of x? We place here, you have 2 minus 1 minus 3 square minus 8. That will be 24. Now when x equal to 7, that will be what? 2, 7 minus 3 square minus 8. That will be 24 as well. So that is good to know. Now let's plot the graph. It is only sketch, so it doesn't need to be exact. So that will be something like this. That will be my value of y, and we know this should be minus 1 here. Let's say minus 7 is somewhere over here. Now, as you can see, we have to find the minimum point. There's 2 ways to find that. The long way is now to use dy by dx to find the stationary point. Because in this question, because we have already changed this to this form, we have to understand that we can just use this to find the minimum point. So this value inside will be the value at which it occurs. So basically x minus 3, equate that to 0, that will be the value of 3. Now look at this value here, that will be the minimum value. So the point, it will be 3 and minus 8, at which we have a minimum value. So the point will be somewhere right here. This is, you have to show this is the point minus 8, and that is 3. So now we just have to show the shape, somewhat the shape. So it will be, at first obviously, that's how you proceed. That will be a curve, and this will be something like this, right? That's how it would look like usually. Now, coming back to this, as you can see here, what do we have? Okay, this one is a mistake here. I missed something. Well, this is pretty stupid mistake because it's not supposed to be 0. It's supposed to be 20 something here. I apologize. Should be something over here. That's a pretty dumb mistake. So let me erase that for now. Don't look at the blue. Let me actually do this on a new page because that might confuse you. So, for example, I realized that the value of x is minus 1. The value of y will be 24. So the point is minus 1, 24. When the value of x is 7, the value of y has to be 24 as well. That will be 7, 24. So, same thing. That will be my y value, my x value. So we know that the minimum point is 3, and then minus 8. That's the minimum point. Here we have minus 1, and here we have 7. This is the where your graph will end, right? This will be the points where you will end. Now, the graph will not go through this at this point, but it will be something like that. Okay, so it's not the first, something like that. It is only a sketch, so it doesn't need to be exact, but the idea is that your graph will be matching those points. At least you have to show that. Now, because we have a modulus graph, y equal to modulus of f of x, right? So everything below has to reflect upwards. So this will be going upwards. Here we have minus 8, that should have to be 8. And this will go something like this. Of course, you have to show this is your 8 point. And then at the end, you have to erase this one, because this is no need for this question. You have to show your modulus graph, which is this, this, and this. This is labeled as y equal to modulus f of x. Okay, so now part 3, we have to find the values of k for which this has 4 distinct roots. So we have to use a graph to understand where can we have 4 distinct roots. So now, if you observe, this is what? This is your y equal to k. So the question is, if you were to draw a line y equal to k, where do we have 4 points of intersection? According to your graph, if you observe, if I draw a line here, I will have 1, 2, 3, 4. It is possible. If I draw a line here, 1, 2, 3, 4 is possible. If I draw a line here, we only have 1, 2, and 3. Not possible. If I draw a line here, We have only 2, so it's not possible. So anywhere between the max and the minimum, it is possible. So k has to be between this is the line 0, right? 0, and the maximum point is 8. So this is the values of k, for which it is possible for us to have 4 roots of that equation. So k has to be between 0 and 8. So as you can see, many questions are connected with each other. We have to use the graph in this case to understand what are we trying to find exactly, and then proceed to understand how to find that answer. That is question number 9. Now let's move on to question number 10. The diagram shows part of the curve y equal to this. It is a cubic curve, okay? Now it is cutting the y-axis at the point P, right here, and the curve has a minimum point at Q. Okay, now find the point of Q. Now you have to know, as always, whenever we see a minimum point or maximum point, we realize that we are looking for dy by dx is equal to 0. So let's first find this. Dy by dx will be what? Pretty easy. That will be 3x squared minus 18x plus 24, equate that to 0. As you can see, everything is a multiple of 3. We can divide by 3 everywhere, right? You will have x squared minus 6x plus 8 has to be 0. Now we can factorize. That will be x times x. This will be 4 times 2. To get minus 6, we have to have minus 4 minus 2. X has to be 2. X has to be 4. Now again, if you don't know how to solve factorization, you can always use your formula to find the following answers. Okay, that will be part 1. Now, the point Q is, well, let's see. So it says, so we have 2 possible answers. Let's find the corresponding value of y. Y will be the value of, replace back in your equation here, that will be 8 minus 9 times 4 plus 48 plus 2. 8 minus 36 plus 48 plus 2. That will be 22. Now for this one, y has to be what? So that will be 4 power 3 minus 9, 16 plus 24 times 4 and plus 2. Let's see what do we get. 4 power 3 minus 9 times 16 plus 24 times 4 plus 2. That will be 18. Okay, so if you observe the graph, what happens here? As you can see, here we have a maximum point first, and then we have a minimum point. So which means this one is your first point, which is the maximum point, and this has to be your minimum point. But here we are trying to find Q, which is the minimum point, which is the point 4 and then 18. So we have to choose this one instead of this one, because according to your diagram, you can see this one happened first. This is your maximum point, should be 222, but we are only caring about the minimum point, so Q has to be 418. Now this is part 1 of the question. Now for part 2, we have to find the area enclosed by the curve and the line PQ. Let's see, what do we have? So here we have a line PQ. We're trying to find the area enclosed by the curve, which is this one, and the line PQ. Pretty easy. Let's break this down into 2 parts. So here we have to connect this one and this one. Right. Now if you observe, how would you find this area? So the idea is that you will first find the whole area and then minus area of this one. Let's call this one number 2. This one. And the whole thing right here, let's call it number 1. So we have to take number 1 minus number 2 to get this area. That's the main idea behind how to do this question. Now, how would you find number 1? Number 1 is area under the curve. We have to find by using integration, right? So let's do that. So let's first find area number 1. Number 1, it will be found by using integration of the curve is y. That will be x to the power 3 9x squared plus 24x plus 2 by dx. Now the limits, as we have seen, is between 0 and 4, right? Because we have seen this here, 0 and 4, that's the limits to find this whole area. So solve one by one. That will give you x power 4 over 4 minus 9 power x power 3 over 3 plus 24 x power 2 over 2 and plus 2x. And that is between the limits of 4 and 0. Solve, that will be 4 power 4 divided by 4, that will be 4 power 3 minus, that will be 3 4 power 3 plus 12 4 power 2 plus 8. That is the first part, and then minus, this will be 0. So let's see, what do we have? Minus 3 power 4 power 3 plus 12 4 power 2 plus 8. That will give me 72 as my answer for the whole area. That is for part 1 only. Now we have to minus area number 2. Now how would you find area number 2? If you observe closely enough, this is what? This is a trapezium. So we have to find the area of trapezium. Now this is the height of this trapezium is what? This is the value is 18, right? 18. The length in between is 4. Now we only missed this value right here. So what is the point P? Let's find the point P. The point P is where the curve cuts the y-axis. So let's see how can you find that. So let's do this. Okay, so let me make a drawing here so we have an idea again how are we supposed to find this. So we have this, and then we have the curve, which goes something like this. Now we have a point here, and this point goes something like this. So we have a point P here we have to find, and this is your point Q. So something we can do here is we can use, there's a few ways we can use find that. So one is using the curve y equal to x power 3 minus 9x squared plus 24 plus 2. As we guys know, on the y-axis, the value of x has to be 0. So y has to be the value of 2. So the point P has to be 0, 2. That's the easiest way of finding that. Now, what we understand is that we have a shape like this now, which is number 2 is something shaped like this. Right? This is 4, this is 18, and this is 2. This is a trapezium. This is my two sides which are parallel, and this is my perpendicular length in between. So the formula states that trapezium, or area of trapezium, has to be half times sum of the parallel side, that will be 2 plus 18, and times the length in between, that will be 4. Half times 20 times 4 has to be 40. So the unwanted area number 2 is 40. So we go back to the main question. As we can see here, so the area of the region enclosed will be 72 minus 40, that should be 32. But always double check because we want to avoid silly mistake. And of course mention the units will be unit square. This is your area of the region that we need to find for question number 10. Now let's move on to question number 11. So answer one of the question. Here we have two questions obviously we can choose from. It is a vectors question. Let's see what can we do. So in the diagram above we have OA is A, okay, OB is B, and OS is 3 over 5 OA. So which means this has to be, on top is 3, and this has to be 2 because everything is 5. OA is 5, 3, 2, right? That's the main idea behind this ratio. Now here, same thing again. OT has to be 7, right? OB is 5, because OT is 7, this has to be 2. That's the ratio between those two lengths. That's what we have from that first line. Now for part 1, given that AX is a multiple of AB, so where's that? AX of AB, okay? Where this is a constant, we'll express OX in terms of this and this and this. So step by step, let's write this down. So here we have AX is mu times AB. Now here we have to understand how to find these one by one. So what is this? So by definition, AX is equal to OX minus OA. Now this is also explained in one of my videos. If you type in vector on my channel, you will find a video explaining why it is this. So it will be helpful for you to understand that. But pretty easy whenever you have AX, or let's say you have anything. Let's say we have to find ST. We'll take the second value first, OT, minus the first value. So that's the main idea behind this, for you to do this as fast as possible. So let's first find this. So let's first replace this here. So that will be OX minus OA is mu times AB, same thing, AB will be OB minus OA. Now, replace the values that we know. So OX we don't know, right? Minus this we know it is A, mu we don't know, this is B minus A. This is given to you by the question. Now, simplify, OX has to be mu B minus mu A plus A. So OX has to be, factorize A outside, you will have what? You will have 1 minus mu A plus mu B. This is part 1 of the question, where you have to find OX in terms of mu A and B. Now for part 2, given that Sx is, we have a multiple again, which is a constant, lambda, St. Express OX in terms of this. So same step, same thing, we have to do again. So same one by one step. So we have Sx has to be lambda St. By definition, Sx is what? OX minus OS. Right? Now replace here, you will have OX minus OS. That will be lambda St will be OT minus OS. Okay, so now we have to replace the values that we know. So X, we don't know what it is. What is OS? Let's observe how can we derive OS. So first thing first, OS is 3 over 5 OA, so pretty easy. Because OA is what? OA is given by A, so that'll be 3 over 5A. That's my first value, OS. Now for the value of OT, OT, pretty easy as well. 7 over 5 OB or BB. Replace the values back in your main equation right now. Let's see what do we have. That will be OS, which is 3 over 5A. Lambda, OT is 7 over 5B minus 3 over 5A. Now simplify to see what can we have. OX has to be 7 over 5 lambda B minus 3 over 5A. And then when you send this, so of course you have to multiply lambda, send this over here, becomes 3 over 5A as well. Now simplify. So OX finally has to be the value of what? Let's write this first. That will be factorize 3 over 5 and A outside. We'll have 1 minus lambda. And then here, same thing. If you can factorize 7 over 5 B, that will be lambda as well. So we can write this again. That will be 3 over 5, 1 minus this A plus 7 over 5 lambda B. Because we can, so in this case we can easily compare the A and the B part. Because of that we write this in this way. Because as you can see, here we have A here, we can compare easily. That's why we write this in this form. Now this is your question part 2. Now you can see part 3, hence using those two answers find the value of these two. So we have to understand that because we found those two, we understood that OX is equal to this value. Now this is my equation number 1, but also OX is also equal to this one, equation number 2. So it means that obviously OX, it has to equal to OX because they are the same thing. So we can equate those two together. For example, you will end up with something like this. You will have equation number 1, which is 1 minus mu A plus mu B has to equal to equation number 2, which is going to be this. So finally, last step is we have to compare the coefficients. So what do I mean? In front of A, we have this on this side. In front of A, we have this on this side. So we have to equate them with each other. So here we have 1 minus mu has to be 3 over 5, 1 minus lambda. So let's solve this to see what happens. So that will be 1 minus mu has to be 3 over 5 minus 3 over 5 lambda. Let's solve. We can send this to this side. You will have 3 over 5 lambda, and minus mu has to be 3 over 5 minus 1 has to be minus 2 over 5. So let's make mu become subject of formula. So mu has to be 3 over 5 lambda plus 2 over 5. That is my equation number 1. Now from here, same step. In front of B we have this part, and in front of B we have this part. So we have to equate them with each other. So mu has to be 7 over 5 lambda. Now, This is my equation number 2. Now, as always, when you have equation number 1, number 2, we can solve them simultaneously. Here we have lambda on one side, lambda on one side. We can replace in each other. Let's see what do we have. On one side, you will have this plus this has to be 7 over 5 lambda. Send all the lambdas to one side, you will have what? So send this over here. That will be 2 over 5 is 7 over 5 lambda minus 3 over 5 lambda. That will be 2 over 5. Here is going to be 4 over 5 lambda. Now simplify, cancel out, cancel out. Lambda has to be the value of half, right? 2 divided by 4 is half. This is your first value of lambda. Now find the value of mu. Replace back in your main equation. That will be 7 over 5 times half. That will be 7 over 10. So finally we conclude that by solving simultaneous equation, lambda has to be half and mu has to be 7 over 10. Okay, and that is for part 1 of the either of the question. Now let's move on to the last one, which is the O part of the question. Okay, so here we have what? So same kind of concepts again. This is still with vectors. Let's see what do we have. So in the diagram above, we have OC is C. Okay, this is given to you by C. OD is D. This is D. Now the points P and Q lie on OC and OD produced. Okay, that's something good to know. And then we have, what do we have? So respectively, so that OC and CP is 1 to 2. So the ratio will be 1 to 2. So OC is 1, CP has to be 2, which means if OC is C, CP has to be 2C, right? If that makes sense. Now, if OD to DQ is 2 to 1, if OD is D, DQ has to be half, right? If you observe, has to be half the value of this. So because of that, or we can, if you want to, we can actually simplify this even better to see how can we use this, for example, so that we don't have any confusion. So ratio can also be written in terms of fraction. For example, we know that OC has been given to you by C and OD has been given to you by D, right? Given to you the ratio of OC to CP is 1 to 2. Now you can rewrite this in terms of fraction. For example, OC over CP is going to be 1 over 2. Now we want to find CP, obviously, so we have to make this become subject of formula. So let's send this over here. You will have CP will be 2 times OC, so CP will be 2C because OC is equal to C. That's the first thing we derive from that ratio. Okay, as you can see here, CP is 2C. That's the first part. Now the other ratio is what? It is given to you by OD. DQ has to be 2 to 1. Now same thing, OD over DQ has to be 2 over 1. OD is given to you by what? By D. That will be 2 cross multiply, that will be DQ, which means DQ has to be D over 2. So this is how we can derive those values as well, one by one, by using the ratio in terms of fraction, so that you don't confuse yourself with anything. This will be D over 2, right? That is, for part 1, we derive the information from this sentence. Now, we can see the line CD is extended to R. The line CD has been extended to the value R, so that CD same as DR. So these two has to be the same. Okay, that's something good to know. Now for part 1, we have to find in terms of C and D the vectors OP, OQ, and OR. So let's first, where's OP? OP is this one, pretty easy. OP, as you can see, is C. So how do you move from O to P? Move from O to C and C to P, that will be 3C. Okay, and for OQ, we have to move from O to D and D to Q. So 1 plus half, that will be 1.5 D. Finally, we have to find OR. So how would you find this? If you observe, OR has to be O. So we can have OD and then DR, because these are the same. Let's find this first. Let's find CD first, because we know that CD and D are the same. Let's find CD. So how would you find CD? By definition, CD has to be what? Has to be OD minus OC. So other way of finding this is to use the diagram. So if you observe, CD, moving from C to D, we can move from C to O and then O to D, which means C to O will have to be minus C plus D. That will be D minus C. Now this is the value of CD, which means that DR also have to be the same value because they are the same. So now we are trying to find OR. O moving to R will be OD and then DR. So OD is D plus DR is this. That should be 2D minus C. If that makes sense. Two pieces, right? OR has to be OD plus DR. OD is D. DR is D minus C. That will be 2D minus C. That's why we get this. Now for part 2, we have to show that points P, Q, and R are collinear. Find the ratio of P, Q, and QR. So to show that they are collinear, we have to show that they are a multiple of each other. So for example, if I have a line, let's say I have P here, Q here, and R. To show that they are on the same line, we have to show that the ratio of PQ, so not ratio, but the length or the direction of PQ has to be a constant of the direction of QR. For example, we can show that if that is the case, if we can find a constant that shows this, it means they are collinear. So let's find this. So let me write down the points. We have the points OP is given to you by, OP was found to be 3C. Then we have the point OQ given by 1.5D, and then OR given by 2D minus C. So let's say we have a straight line. We want to prove that P, Q, and R in the same direction. The idea is that we can take PQ has to be a multiple of QR. That's one way of writing that. It can be many ways because we just have to show it is in the same direction. So we can also show that PR has to be M of QR. That is one other way to show that. So the main idea I took is I took this line. I want to say it is equal to a constant multiplied by this line. That is one way of doing that. If you can choose, that. There's many other ways. But the main idea is you have to find a constant between those two length. Okay, so PQ is what? It is OQ minus OP. So OQ is 1.5D minus 3C. K we don't know. And OQR is what? It is OR is 2D minus C minus OQ will be 1.5D. So let's simplify. That will be what? That will be 1.5D minus 3C, okay? That will be K, and that will be what? That will be, so 2D minus 1.5 is 0.5D minus C. Okay, so now to find D, we can simply do what? We can send this over here. That will be 1.5D minus 3C over 0.5D minus C. Now if you observe something, K has to be, if you take out the value of 3, you will have 0.5D minus C over the value of 0.5D minus C. As you can see, we were able to obtain a constant K. So since K is 3, which means that the direction of PQ is a multiple of direction of QR. Because of that, we have shown that P, Q, and R are collinear. That is one way of showing that they are collinear. So after I know they are collinear, I will have to find the last part of the question, which is the ratio of PQ and QR. So as we have realized that our ratio here was given to you by what? By PQ has to be 3QR, right? So PQ and QR is what? It is PQ divided by QR has to be, so we send this over here. So PQ divided by QR has to be 3 over 1. So the ratio has to be 3 to, so 3 over 1 has to be, which means 3 to 1. So this is your final answer for the question, part 11. Find the ratio PQ to QR. It is 3 to 1. As we have seen, we have found the value of K first, and by finding an exact value, a constant value, we have shown they are collinear. after that, using the same value, we can find the ratio to show this. Okay, so that will be the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching. I will see you soon.